Welcome everyone. I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 2, which is add two numbers. It is a linked list problem. Let's see the problem description. You are given two non-empty linked lists representing two non-empty integers. The digits are stored in reverse order and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zeros except the number 0 itself. So we will be having two integers. The digits are stored in reverse order, and in a node of a linked list, it contains only a single digit. And let's see the constraints. The number of nodes in the linked list will be 1 to 100. The value of each node, we know the digits, so it will be from 0 to 9, and it is guaranteed there will be no leading zeros. So what we can do, first we need to add the current two, let's say the nodes of the two linked list. Let's say for this example, 2 and 5 will be added. It will be stored as 7, and the extra means if we add two numbers, the maximum possible sum could be 18 because 9 plus 9 is 18. So the extra means we need to store only one single digit to the linked list, and the extra will be added for the next linked list nodes. Okay, so the here 5 and 2 added to 7, and the extra is 0, and that will be also added in the next two when we are adding next two nodes. Let's say 4 and 6, which is 10 plus 0 from the previous, so which is also 10, and the now the digit is 0 and the extra is 1, which will be added to the next two nodes. So now here it is 4 and 3 7, and the previous extra is 1, so total 8. This is how we have to do it, and the length of the two linked list will not be same. So that means there could be like 2 4 3, and it could be 56 only. And then we need to take the previous extra to the this linked list only for one node. And after finishing all, like calculating all the sum, then also there could be one extra, like for example 9 and 9. If we are adding two linked lists which will have only two nodes, 9 and 9, so the sum will be 9 plus 9 18, and we are adding 8 as a digit in a one linked list, and up we have finished all the linked list nodes. Now we have also one extra, which is 1. So we have to, after adding traversing both the linked list, if both the linked list are finished, then also we have to consider that if there is one extra remaining or not, then also we have to add it in the our answer linked list. So let's see how we can do that. First we need the list node head of the answer linked list. So let's say head. Initially it will be null pointer, and also we need a current end pointer, which will be pointing to the current end, because every time we need to add a new linked list, we will just add it to the end next, and we will shift the end to the current. Okay, so we need, and we also need the remainder or the extra, let's say extra of the which extra will be initially 0 because we do not have any other nodes previous of the first node. Now while both L1 and L2 are present, that means we have two nodes. First, we will calculate the sum of three of them, like the extra, previous extra, plus L1 of value and plus L2 value. Now we have the sum. We need to calculate the current value of the answer linked list. The digit we need to store the current linked list. So that will be, let's say, value equal to, that will be sum modulus of 10, and the extra will be sum divided by 10. So let's say the sum is, let's say, 14. So the value that we are going to store current in our current answer node, that will be 4, because 14 more 10 will be 4, and the 14 divided by 10 will be 1. So the extra will be 1. That's how it is going to be happen. So now we need to create a new node with the value of this. So let's say list node star temp, or let's say current is the new list node of value this. Now we need to add it to our answer list. So first we need to check if the head is present or not. If the head is not present, that means it is the first node, or the current node will be the head of the answer list. So head will be same as end, and that will be current. Okay, and otherwise is the end next will be the current, and we'll shift the end to current. Okay, that's it. And after that, we need to shift the two pointers also to move L1 equal to L1 next, and L2 will be L2 next. Okay, now this will do the work of when the two linked lists are not equal. We need to consider that case also. If the linked list to length of the two linked lists are not equal, that means after this first while loop, only one linked list is remain. So while let's say L1, we also do the same for L2 also. So let's say L1 is now available. So first we need to check the sum. The sum will be extra plus L1 value, and there won't be L2 because L2 is already empty. As the L1 is present, that means L2 is already finished. Okay, and the rest of the code will be the same. I am just copying this from the previous code. So the value after sum, the value will be the same, extra will be the same like this. We need to create the current, and we do not need this because after the first loop, we already have the head. We can just write this instead of the whole code. So we can just write this because we already have the head of the linked list, our answer linked list. So just answer next will be the current, and we will shift the end to the current, and L1 will be L1 next. And we also have to do it for the L2. If L2 is present and L1 is not present, so this inner code will be the same, just replace the L1 with L2. Okay, the L1 will be L2 value, this will be the same, and shift the L2 to L2 next. Okay, that's it. Now we have calculated the sum, but if the remainder is still present, or the extra is still present, because if extra is present, we need to add it to the last of, or at the last of the answer linked list. So if the extra is present, then the end next will be new list node extra, or you can replace the extra with 1, because the maximum extra will be 1 and minimum will be 0, because maximum sum is 18, so the extra could be maximum 1. Okay, so I am writing just extra, and after that you need to return the head. Okay, that's it. Let's see will it work or not. It is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. So the time complexity is we are traversing for both of the linked list one time, and if the linked list is still present, if the one linked list is end and the other one is still present, we are also traversing the row. So the overall time complexity will be big of maximum of length of L1 and L2. Okay, because let's say the time complexity big of n, where n is the maximum of the length of L1 and L2. And the space complexity will be big of n, where n will be the length of the answer, after adding the two numbers, the length will be the our space, the maximum space we are, because we are storing all the digits of that number, answer number, in each of the linked list. So the overall space complexity will be big of n, where n is the length of the answer digit. Okay. So thanks for watching. If you want to check out the code, you can find it in the description box below. So that's it for today. See you in the next video.